This is John from caveofprogramming.com. In this tutorial we're going to take a look at the left bit shift operator, and we're going to see how we can pack a bunch of colour values into a 32-bit int. So we want to be able to specify red, green, blue and alpha values as hexadecimal values in unsigned chars, because the values of our red, green and blue range from 0 to 255, which is 0 to FF in hex. But to actually set the values of pixels on the screen, we need a unsigned integer colour. That's a 32-bit value on most platforms, in other words 4 bytes. And we want to put the alpha value in one of those bytes, the red in another byte, blue in another and green in another. So the exact order of these is it depends on what API you're using. And they can also be the other way around. But just for a demonstration here, let's imagine that we want to put the alpha in the leftmost byte of this integer, and that followed by red and followed by blue and green. So if we've got values FF and 1, 2, 3, 4, 5, 6, I've just given these easily distinguishable values. We want the resulting hexadecimal value to look like this. So because it's in hex, and because 2 digits in hex corresponds to 1 byte, then we can easily see these values in the final integer. That's the advantage of using hex. You've got that one-to-one correspondence between 2 digits in hex and a byte. So we want the alpha value to be here, and then the red value, and then the green value, and finally the blue value. How can we accomplish that? Well, we've got this unsigned int colour here. Let's start by setting it initially equal to alpha. We want to output this. We want it to look something like that. Let's use cout here and colour endler. And if we run this, the first problem we find is that I'm not sure what those errors are, but they sort of disappear. And yeah, we've got some unused variable warnings. That's fine, I haven't used them yet. So when we look at it, it's in decimal. So I'm going to use iomanip. Let's include iomanip. And this allows us to manipulate the output a bit. So one thing I can do is type hex here, and this object or flag, whatever it is, that's going to tell cout to display subsequent values in hex. So if I run this now, we get a hex value. Now I'd like to see the whole thing. I'd like to see, we've got an 8-digit unsigned int here. 8 digits corresponds to the 32 bits. 8 digits in hex corresponds to 4 bytes or 32 bits. So I'd like to see this left padded with zeros, because just as in decimal, we can left pad a number by zeros and it makes no difference to the value. So to do that, we can set the width here. Let's say set width, and set it to 8. Actually, yes, I think that's right. So we want to set it to 8 digits. If we run this now, now we can see that the width is set to 8 digits, but it's padded with blanks. So what I'm also going to do here is I'm going to say set fill, and set the fill character for the extra values in the width here to 0. And if we run this now, we see that we've got a hexadecimal integer formatted as we like. So we can see that these rightmost values, the least significant bit here, the least significant byte I should say, are set to FF, and the others are still 0. Now what we can do is we can use the left bit shift operator. Let's say colour equals colour left shift by 8 bits. So what this does is simply to move the bits to the left and right pad with zeros. So by doing this, we're going to move all the values in the colour left by 8 bits, which is 1 byte, which remember corresponds to 2 digits in here if we use hexadecimal. So any values that were on the right here would simply drop off, on the left would simply drop off the end, and would pad with zeros, and the FF is going to move along two places, which corresponds to 1 byte. So let's run this, save it first. And now we can see that we've got the alpha value there shifted a bit closer to where we want it. Let's move it by 3 bytes, which is 24 bits. So now we've got it into the right position there. But what we can actually do is we can build this up as we go along. So let's add the alpha and then shift it. In fact, rather than use this syntax, in the same way that we wouldn't want to say color equals color plus 5 or whatever, we would want to say color plus equals 5. We can also do equals shift, and that means the same as what we had previously. So that's actually not right. We want to say shift equals. Okay, let's do that. Shift equals, just like plus equals. So if we run this now, we can see we had the same result as before. It's shifting the color left by 8 bits and then storing it back in color. We can then let's set this equal to 0 to start with, and then let's say color plus equals alpha, and then shift equals by a byte. Then we can say color, and we can add on the next value, which is red here, and when we add it, it's going to fill this empty space on the right. Let's say red. Let's take a look at how that looks. So now we've got red after the alpha value, and of course we can shift it again by another byte and then add on green. So now we should have the green value as well in the right place. And finally, we want to shift it again by another byte and add on the blue value. So color plus equals blue. So if we look at this now, we've got exactly what we wanted, which is this. We've got FF 1, 2, 5, 6, 3, 4. I think I've got them slightly in the wrong color. Red, blue, green. Yeah, we should have red, green, blue. So let's declare them in the other order, although it doesn't actually matter. And let's set green to 3, 4, blue to 5, 6, and then we should have 1, 2, 3, 4, 5, 6. FF 1, 2, 3, 4, 5, 6, which is exactly what we want. So the bit shift operator, left bit shift, is it's not used all the time in C++, but it is very useful for some tasks, particularly because in C++, you often, it's kind of a low-level language where you often want to shift bits and bytes around like this. And there's also a right bit shift operator that shifts the bits to the right as well. So we'll leave it there for this tutorial, and in the next tutorial we'll look at using this to set pixel values. So until next time, happy coding.